What I would like to talk about today is actually the relationship between product management and data science. Yeah? And as you can already see from the slightly provocative title, there is some friction between these two parties. But before I start the talk, actually, I would like to do a quick survey. So who of you actually has a data scientist background? So please raise your hand. OK. How many of you has a background as a product manager? OK, great. And how many of you are on the managing level, executive level? OK, great audience. I will enjoy it. So let's start with some very basic. Yeah? So what is actually a product? Yeah? So what I consider as a product here is something created and made available to external or internal customers. And what I have in mind is actually kind of software applications. Yeah? To give you an example of a classical e-commerce platform, for example, Zalando or Amazon. So it's composed of a lot of products, actually. Yeah? So front end is composed of registration, authentication. You have the checkout as a product. You have the recommender engine as a product. Article search. So a lot of products that contribute to the overall success of the platform. But there are also products in the back end. Yeah? So inventory control, you have the order engine, you have logistics processes, the payment service, or even the payment control, a product that decides who gets what payment method offered. Yeah? So a lot of products, and this is what I consider here as products. For the rest of the talk, I would like to consider the following very simplified platform, which just consists of a registration. Then you have an article search. Maybe you show some article details where you can put stuff into the cart. And you have the checkout and some payment control system. So this will serve as the example throughout the entire presentation. OK, so now it's clear what's a product, but what's product development? In a nutshell, it's just the modification of some products, differing new features to the customer, and of course, creating value, additional benefit to the customer. Which brings us to the first question, how do we actually measure such benefits? Yeah? And for this, of course, you have to define KPIs. Yeah? For instance, let's take, for example, the example of the article search. One meaningful KPI to measure the performance of the product might be the search rank, on which the rank of the item or the article on which the customer clicked when he searched something. But on the other hand, you also need to measure KPIs globally, not just locally. Why is it? Because not every KPI that is improved locally will also improve the global performance of the overall platform or product. Again, to give you the example with the search rank, you could easily improve the search rank by just reducing the assortment. Instead of presenting the customer 1,000 articles, just present them 10. If you present them 1,000, maybe some customer will click on number 915. If you only present them 10, I'm pretty sure the search rank will be below 10. But if you look on the overall performance of your company, so your revenue will definitely go down, because customers don't find anymore maybe what they want to buy. So that's why it's important to not just measure it locally, but also globally. OK, but this is just how you measure the performance of the system. How do you measure that you improved it? And for this, of course, you should always do A/B tests. Yeah, so 50% of your customer interact with the old version of the product, 50% of the customer interact with the new version. And you measured the difference in the different KPIs. And if everything looks great, local KPI, global KPI, everything improved, you can deploy and you have further developed your product. What will change if you do data science? And to start with, let's first of all make our system slightly smarter. Yeah? The old product, let's assume the payment control just worked with some external solvency score, which decided, OK, if solvency is too low, we simply don't offer open invoice. We just offer prepayment. So you hire a data science team and give them the task, make it smarter. And the data science team comes up with a solution which tells you, well, if we measure the customer engagement and include this into our logic, this would have a great improvement on our fraud detection. And if you ask them, how do you actually measure the customer engagement, they will tell you, well, we just measure the time that it takes a customer to put an article into the cart. Yeah, so we measure the time from article search until stuff gets into the cart. And then we take the average time, so divide by the number of articles, and this is how strongly the customer engage. Why is that a good fraud predictor? Because usually a fraudster, he knows very well what he's looking for. Yeah? He's looking for the most valuable item in your store, which has the highest resale value. So you deploy it, you measure it, you improve your conversion, you globally improve the profitability, you reduce the losses. Great idea, great achievement. But what happens to the overall product landscape? So there's still this product manager from the article search team who wants to bring up this great idea how you can improve the article search. What happens if he now deploys or runs his A/B test? And what he will experience is the local performance looks great, yeah? So the search rank improved. But if you look on the global performance of this overall system, then you find out, well, the revenue went down. And he can't understand anymore what happened. And the reason is quite simple. He broke the logic of the payment control system. Of course, he did it accidentally, but he wasn't aware that there's a strong dependency between the two systems now. Because people are much faster in searching the articles, putting it into the cart, and the interpretation of the payment control system, oh, everyone is a fraudster. Yeah, so you simply didn't offer open invoice anymore. And this really is an issue. And this is an issue that is introduced by a strong coupling between products introduced by data science. Okay. But it's not just the problem for the product manager of the article search, it's also an issue for the payment control system. Because someone broke a system from the outside. Two issues. Let's start with the second. How can I protect, as a product manager of the payment system, that someone breaks my system from the outside? So the first thing, and this is special advice to the data scientist, whenever you build something, some logic, you have to thoroughly monitor your data inputs into that logic. Monitor deviations from the training data. Yeah, so does your live data differ from, from the data you trained your model on? Second of all, you have to make all these dependencies explicit. What do I mean with an explicit dependency? So take the same example that you want to measure the customer engagement by the time it takes to put an article into the cart. If you use the data from the article search, it's an explicit dependency. But you could also do it differently. Yeah? You could say, well, what's the time between registration and customer show up in the checkout? It also measures the time. Yeah? Just divide by the number of articles, and you have a very good proxy for the time it takes to put an article into the cart. And usually data scientists tend to create sparse solutions. And by this, they would implicitly measure the performance also of the article search. And this is what I consider an implicit versus an explicit dependency. So try to make it explicit. Third of all, teach everyone about what you created. Yeah? You really have to tell every product manager that there's a strong dependency between the products, and that is a data dependency. And you, of course, you should document it. So this is my hint to the product manager and the data scientist. But what to do in case of the product manager being responsible for the article search? He is still in the situation that he can't deploy without breaking your logic. So first of all, now he knows or she knows that there is a strong dependency to the payment system. So speak to the other product manager first and agree upon the following steps. First step, you have to convince the payment control, the person in charge for the payment control, that he deploys a logic which is independent from the article search. In our case, we would roll back one version. Yeah? This would then allow us to run the A/B test. We can measure the performance, and if everything is fine, the product manager article search can deploy the new version. But still, we can't switch back to we can't switch on the payment control logic, the superior payment control logic, because it still would receive data it can't interpret. So what does it mean? We switch the new version of the article search live, but we have to collect data, because without data we can't train the system. Okay, so we collect data for the payment control logic, and then again the data scientist at the payment control side has to become active, retrain the logic, deploy it, and then you are done. What does it tell us? And this is also the answer to the provocative question of at the beginning of the talk. It will make product development much more expensive. Yeah? If you introduce data science, the costs for further developing your product will increase. Yeah? And due to all these strong dependencies, the coupling between products, you can easily break other systems. Yeah? So a product which uses data science is quite fragile. So, to sum it up, I would like to give some recommendations. And one goes to the executives. And this is really, you should not underestimate the cost of data science. Data science is very costly. There is no free lunch. Of course, you can have a great improvement of your system, but you also have to pay for it. Second of all, when it comes about prioritization of features, what should be built next? You should do it according to the return of investment. Yes, of course, you should take into account the business value of the feature, but you should also take into account the total cost of building this feature. Yeah, in the past, it was, okay, what are our development costs? Maybe some costs for A/B testing. But now you have the development cost, you have maybe even higher costs for running an A/B test, you have the costs for acquiring the new data, and you have the additional efforts from the data science team. Makes it much more expensive. Third point to the management, bring together product management and data science. Bring them together as close as possible. A lot of companies currently struggling with the question, should data science be part of tech? Should it be part of product? Should it be an isolated pillar? And everyone is trying different approaches. My recommendation is product management, data science, bring them together. I don't mind if they report to a chief data officer or a chief product officer. I think it's a decision that should be made based on, okay, how important is data science for the overall, for your company. Furthermore, you should centralize all the A/B testing and personalization efforts in one department, and it should be the data department. The reason, so I think this would be a completely separate talk I could give on that, but mainly because there are so many dependencies between all the products, and if you want to do A/B testing right, sometimes you even have to couple a test between different products. So that's why if you centralize it, it will have an advantage. Also, the data guys would get an early warning that something is going on in the product landscape. So a lot of reasons why to centralize it in the data department. To the product manager, my recommendation is map out all the dependencies, especially all the data dependencies, because usually they might be implicit. So really document them so that you don't accidentally break someone else's product, but also protect your own product from being broken from someone else. And finally, to the data scientists, build monitoring and alerting systems. If your logic consumes data and provides an answer, so I mean, what is a logic? It just computes a function, right, f of x. And of course, it will still compute a function, even if it gets weird inputs. Yeah? So it can even break silently, yeah, or slowly, yeah, if the data just drifts. So you should have a monitoring system. Otherwise, you will be sooner or later in trouble. And as I mentioned before, you should prefer explicit over implicit data dependencies, because this would allow you to create solutions like data as a service, where you can explicitly consume the data from a different product, and the product would know that you are consuming it. You could add metadata to it, so a lot of advantages. And finally, you should create sparse solutions. But sparsity here rather means don't take everyone's data. Yeah? So rather try to limit the dependencies to other products. The less dependencies, the more stable your product will become. And of course, it's your responsibility as a data scientist to educate the product management. Yeah, and by this, I would like to thank you.